Propane C3H8 boiling point of -42 degrees Celsius is used as camping gas. A student plans to determine the enthalpy change of combustion of propane by two methods. Part A. The student first carries out an experiment using the apparatus below. Part 1. Determine the enthalpy change of combustion of propane in kilojoules per mole, and give your answer to three significant figures. Let's start by highlighting the key pieces of information in this question. So that's going to be the molecular formula of propane, the results table, and that we want our answer in kilojoules per mole to three significant figures. So the first equation we're going to use in this question is that Q is equal to M times C times delta T. So M is going to be mass, and that's the mass of water, as that's the thing we're heating. So that's going to be 100 grams, because 1 gram of water equals 1 centimetre cubed of water. C is the specific heat capacity of water, which is 4.18, and that is joules per gram degrees Celsius. And then delta T is the change in temperature. So that's going to be 46.10 minus 21.60, which equals 24.50 degrees Celsius. So then we can plug in these numbers into the equation and we get Q, which is energy. So Q is equal to 100 multiplied by 4.18 multiplied by 24.5. So that's going to equal plus or minus 10,241 joules. But we want this in kilojoules eventually, so Q is equal to plus minus 10.241 kilojoules. So now we're going to work out moles, and we're going to do this using an equation triangle. And the equation triangle we're going to use is that mass is equal to moles times the relative formula mass. So if we work this out, we need mass and relative formula mass, and we're going to divide them. So the mass of propane we can calculate in the results table. That's going to be 99.218 minus 98.976, which equals 0.242 grams of propane, so C3H8. And we can work out the relative formula mass of propane by doing 12 times 3 plus 8, which equals 44. Now we can work out moles by simply dividing them. So we've got 0.242 divided by 44, which equals 0.0055 moles. So now we've got kilojoules and we've got moles. So to do kilojoules per mole, we do 10.241 divided by 0.0055, which equals 1,862 kilojoules per mole. But we don't know if it's plus or minus. However, we do because we know we're working out enthalpy change of combustion, and enthalpy change of combustion is exothermic, which means that it's going to be negative. So on the answer line, we need to make sure we're giving our answer to three significant figures, and it's going to be negative. So minus 1,860 is going to be what we put on the answer line for this question. To get the 3 marks for this question, you get a mark for working out your kilojoules or your joules. You get a mark for working out the moles of propane, and then you get a mark for working out the enthalpy change of combustion of propane and writing it to 3 significant figures. So minus 1,860 gets you your 3rd mark. Part 2. The student finds that the experimental enthalpy change is much less exothermic than the accurate standard enthalpy change in databases. One reason could be that the student's experiment had not been carried out under standard conditions. Suggest 2 other reasons for this difference in enthalpy change. So for this question, there are 3 categories of answer, and you need to pick 2 from the 3. The first category is that heat is lost or released to the surroundings. The second category is that you have incomplete combustion, or a reaction with oxygen/air, or you could have said that not everything burns. That's your second category. And then your third category is that you've got an evaporation of water. To get the mark for this question, you need to pick 2 of the 3, and you need to have 2. You can't just have 1 and you can't have 3. You need 2 of the 3 categories. Part B. The student determines the standard enthalpy change of combustion of propane using the bond enthalpies in the table. An experiment is not needed. The bond enthalpies can be used to determine the standard enthalpy change of reaction for equation 3.1. Enthalpy change of vaporization. The standard enthalpy change of vaporization of water is the enthalpy change for the conversion of 1 mole of H2O liquid into 1 mole of H2O gas under standard conditions. Determine the standard enthalpy change of combustion of propane, which has a boiling point of -42 degrees Celsius, using the standard enthalpy change of reaction value for equation 3.1 and the enthalpy change of vaporization for water. So in this question, let's start by drawing out how our reactants look with the bonds and our products, but starting with the reactants. So drawing out propane, we have C3 and then we have H8. So that means we've got 8 carbon hydrogen bonds. Then we need to draw oxygen. So oxygen is going to be an O double bonded to an O, or an oxygen double bonded to an oxygen. So those are our reactants. Then if we look at our products, we have carbon dioxide and then we have water, so H2O here. So the way to remember how to do this question is if we treat this arrow as a negative sign, we're going to minus the bond enthalpies of the reactants from the bond enthalpies of the products. So that's going to be 2 times 347, because we have 2 carbon-carbon bonds singularly bonded. Then plus 8 times 413, because we have 8 carbon hydrogen bonds. And then plus 5 times 498, because we have 5 oxygen double bond oxygen bonds. And this equals plus minus 6,488 kilojoules per mole. Then if we look at our products, we have 6 times 805, because we have 2 carbon double bonded to oxygen in carbon dioxide, and we have 3 of them. So 2 times 3 is 6, and then we've got 6 times our carbon double bond oxygen, so 805. And then we need to add 8 times 464. So that's our water. We've got 2 oxygen-hydrogen bonds, and we have 4 of them, or 4 waters, so 2 times 4 is 8. And this equals plus minus 8,542 kilojoules per mole. So remembering that the arrow is the negative sign, we do 6,488 minus 8,542, which equals minus 2,054 kilojoules per mole. But we're asked to account for the enthalpy change of vaporization for water. So this is our delta RH value, so our enthalpy change of reaction value. But accounting for the enthalpy change of vaporization, we do our enthalpy change of reaction minus 4 times the enthalpy change of vaporization for water. And that's because we have 4 waters in our reaction. So doing this, we do minus 2,054 minus 4 times 40.65. So we get this number from here, which is the information in the question. And that's how you go from liquid water to gaseous water. And that's going to equal minus 2,216.6 kilojoules per mole. The mark scheme will also accept if you round up, so you write minus 2,217. This will also get you the mark. So this is a level response question, which means there aren't specific marking points. Instead, to get the 6 marks, you need to calculate your enthalpy change of reaction for reaction 3.1 correctly with the correct sign, which we have done, that's minus 2,054 kilojoules per mole. And we need to calculate a value for the enthalpy change of combustion of propane using the enthalpy change of reaction and for enthalpy change of vaporization. So that's what we've done at the bottom here. That is going to be our enthalpy change of combustion for propane. And then that's how you get your 6 marks. So it's the first part, laying that out properly. So you've got your bonds made and your bonds broken, and then your next part of minusing your 4 vaporization enthalpies of water.